take this time to go over all of the questions on the review. And just to preface this by saying it's going to be a lot of questions. I want you guys to get ready because the test is also going to be 20 questions. So we're going to go over this. I'm going to do my best to kind of explain my process for these questions, but ultimately, the best way for you guys to improve on this is to try it on your own. So hopefully you're trying this and then you're watching the video as a way to make sure you know what you're doing. So the first 8 questions, I'm going to use identities to try to simplify these expressions. Okay, so let's look at number 1. Number 1 says secant squared x minus tangent squared x. Now, there's an identity, one of them that we've used in the past, that says 1 plus tangent squared x equals secant squared x. Okay, so if I actually move that tangent squared to the other side with subtraction, and if I do that algebra, I'll get 1 equals secant squared x minus tangent squared x. And that's what we have right here. Right? If you look at this problem, we have secant squared x minus tangent squared x, which is the right-hand side. So this is the same as 1. Let's look at number 2. Number 2 says sine of x times cosecant squared x. All right, so if I were to break that up, I have the sine of x over 1 times 1 over sine squared x, right? Because cosecant and sine are reciprocal trig identities there. So I'm going to just do 1 over, and now I have sine of x over sine squared of x. That's going to reduce to, go this way, 1 over sine of x, right? And 1 over the sine of x is the same as cosecant x. Okay, number 3. Now, number 3, right, when I look at this one, I have cosine squared x times secant squared x minus 1. Okay, so when I look at this one, what I'm going to do, all right, is I'm going to take that secant squared, all right, and I'm going to put that as 1 over cosine squared x, okay? So, actually, you know what I think I'm going to do? I'm going to use 1 plus tangent squared x equals secant squared x. Yeah, that's what I'm going to use. That same identity I used for number 1, I'm going to use here, because if I move the 1 over with subtraction, I get tangent squared x equals secant squared x minus 1, which is exactly what I have. So now I have cosine squared x times tangent squared x. So I'm substituting using that identity. All right. Now tangent squared is the same as sine squared x over cosine squared x. And you'll notice that my cosine squareds, one is in the numerator, one's in the denominator, so they cross out and leave me with just sine squared x. All right. So I'm going to go with that. Number 4, sine squared x over 1 minus sine squared x. So I'm going to use one of my Pythagorean identities, which says sine squared x plus cosine squared x equals 1. And if I go ahead and move the sine squared over with subtraction, I'm going to get cosine squared x equals 1 minus sine squared x, which is what I have in my denominator. So in my denominator, which currently says 1 minus sine squared x, I'm going to replace that as cosine squared x. And then sine squared x over cosine squared x, we just used that before in number 3, but that's the same as tangent squared x. All right, let's go to number 5. Number 5 says the square root of cosecant squared x minus 1. So there's another Pythagorean identity which we haven't used yet. We've already used 2 of them, right? In number 1 we used 1 plus tangent squared x equals secant squared x. So that's one of them. We've also used sine squared x plus cosine squared x equals 1. So that's another identity. The third Pythagorean identity is 1 plus cotangent squared x equals cosecant squared x. So if I subtract 1 from both sides to move that over, I get cotangent squared x equals cosecant squared x minus 1, which is what I have as my radicand, right? Radicand is just whatever's inside the radical. So I'm going to replace that cosecant squared x minus 1 in my radical as cotangent squared x. Now you guys learned in algebra that taking the square root of something squared just leaves you with that something to the first power. So the answer here is just going to be cotangent x. Okay, let's do number 6. Now, number 6, it looks like we can factor out secant squared. They both share secant squared x. So I'm going to factor out secant squared x, and I'm left with tangent squared x plus 1. Again, if I use, that's a little nice here. If I use that Pythagorean identity, 1 plus tangent squared x equals secant squared x, right, you'll notice I literally have that. I know the order is a little different, but we have 1 plus tangent squared x in the parentheses. It's just the order switch, which is okay, right? With addition, the order doesn't matter. So I'm going to replace in the parentheses tangent squared x plus 1 with secant squared x. And when you multiply a square times a square, right? If you did think of doing x squared times x squared, you'll get x to the 4th power. So this is secant to the 4th power of x. All right, number 7. Now, what I want to do for number 7 is I'm going to break it up into 3 things. So tangent of x over 1 times cotangent of x over 1 divided by cosine of x over 1. Now, the first thing I notice is if I leave the tangent of x, or I'm sorry, if I leave that alone and change cotangent of x over 1, cotangent, if I wrote that as its reciprocal, would be 1 over tangent. And then if I change this to multiplication, I would put that as 1 over cosine of x. Now, if you look at this, I have tangent of x in the top and tangent of x in the bottom, so those are going to cross out, which leaves me with just 1 over cosine x. And I'm going to write that as its reciprocal, and its reciprocal is secant x. Okay, last one in this section. Secant x plus tangent x times 1 minus sine x. I'm going to just distribute this, all right? So I'm going to take secant x and multiply it by both of those. So that's secant x minus secant x sine x, and then tangent of x times each as well, plus tangent of x minus tangent of x sine of x. Okay? Now, one of the strategies that I mentioned to you guys earlier in this unit is to go ahead and, when in doubt, change things to be sine and cosine. So I'm going to change all of these to be sine and cosine. So secant x is 1 over cosine of x minus, this is going to be, secant is 1 over cosine of x times sine of x over 1 plus tangent of x. I guess I could write that as what I said to do, which is sine of x over cosine of x minus sine of x over cosine of x times 1 more sine x. Okay. Now, I know it might not be something you see with your brain right now, but this right here, negative sine of x over cosine x and positive sine of x over cosine x, that actually is going to make 0. All right, so again, the negative 1 times sine of x is sine of x. Cosine x times 1 is cosine of x. So these are actually opposites. So they're going to go away, which leaves me with 1 over cosine of x minus sine squared x over cosine x. And we have a common denominator. So I can go ahead and write this as 1 minus sine squared x over cosine x. And if we use one of our Pythagorean identities, which says sine squared x plus cosine squared x equals 1, and we move the sine squared x to the other side, we get cosine squared x equals 1 minus sine squared x. So I'm going to replace in this numerator where it says 1 minus sine squared x, I'm going to replace that with cosine squared x. And cosine squared x divided by cosine of x is just 1 cosine x. So I know that was a lot of work to get just cosine x, but again, the key thing here I think will help you is to change things from whatever you've got to sine over cosine or sine and cosine. So always, when in doubt, change things to be in terms of sine and cosine. Okay, let's move on into the next section, which is 9 through 15. It's going to be more of the stuff that we've done in the last week of this unit. So I'm currently recording this the week before Thanksgiving. We just did the lesson on our double angle identities. So you'll notice some of that going on here, okay? Okay, number 9. Number 9 says sine x cosine x. Now, it's really close to looking like one of our double angle identities, which says this 2 times sine x cosine x. So what we did in class, and what you might have watched in the video if you weren't in class, is that you make it have a 2 in front, but you've got to take out a 1/2, right? Because 1/2 times 2 gives us that 1 that was at the beginning of this problem. So this becomes 1/2 times the sine of 2 times our a, which in this case is x. So the answer I'm looking for is 1/2 times the sine of 2x. Okay, let's do number 10. Now, number 10 is one of these sum or difference identities. All right, I noticed that there's cosine, both cosines first, and then subtraction of both sines. So this is actually going to be the same as the cosine of a plus b, which in this case is pi over 2 plus pi over 3. So that becomes the cosine of pi over 2 plus pi over 3. If you get a common denominator of 6, that's going to be 3 pi over 6 plus 2 pi over 6. So we get 5 pi over 6. Now, I'll take this as the answer. That's fine. But I can actually find what the cosine of 5 pi over 6 is. All right, this is 0. This is pi over 2 or 3 pi over 6. This is 6 pi over 6. 5 pi over 6 is in the second quadrant. Okay? And the reference angle, right? The reference angle is pi over 6. So I just need to find the cosine of pi over 6. All right? And because, if I remember my all students take classes, because I'm in the second quadrant and I want cosine, I really need to find what this is and make it negative. All right? So if I do that, the cosine of pi over 6 is the same as 30 degrees. All right? So the cosine of 30 degrees is the square root of 3 over 2. If I make it negative, I have my answer. But again, if you stopped with cosine of 5 pi over 6, that's fine too. All right, but I want to see all of your work, guys, so make sure you show me photos of all of your work. Okay, let's go to number 11. Now, number 11 says 1 minus 2 sine squared of 45 degrees. This is the same as the cosine of 2a, which in this case is 45 degrees. So I multiply 2 times 45, and I get 90. You can leave it like this, cosine of 90 degrees, but again, we've done this quadrantal before. 90 is right here. That's 0, 1. Cosine is x over r. R is always 1, and in this case, x is 0 for my ordered pair. So the cosine of 90 degrees is 0. Let's go to 12. 12 is similar to 10. It's one of these sum or difference identities. Now, when I see sine and cosine together first, and then minus cosine and sine, this is going to be the difference of two angles, and you have sine. So this is the sine of A, which is 300, minus B, which is 15 degrees. So that's going to be the sine of 285 degrees. I don't know that one, right? Because that reference angle is not a reference angle that I know. So what I'm going to do is I'm going to go to Desmos and tell me what the sine of 285 degrees is. All right, make sure you're in degrees. So the sine of 285 degrees is negative 0.966. All right, so negative 0.966. All right, so again, there's the answer, or you can leave it like that. Okay, let's go to 13. Now 13 is one of these tangent ones, and after the, as I'm doing this, we haven't done this in class yet, but the lesson posted today, so hopefully you'll get a chance to watch the tangent identities. So we haven't done any with tangent. But this one says tangent of pi minus tangent of pi over 3 over 1 plus the tangent of pi times the tangent of pi over 3. So this is actually the tangent of pi minus pi over 3. Okay, so if I get this as a common denominator, right, that's going to be 3 pi over 3 minus pi over 3. So this becomes the tangent of 2 pi over 3. All right, now we can do this one as well. You can leave it like that, that's fine, just move on. But if I look at my, this is 0, this is pi over 2, right, and here is pi. Right, so halfway around to pi is 3 pi over 3, so we're not there yet. We're in the second quadrant again, and my reference angle between pi and 2 pi over 3 is pi over 3. So I need to find the tangent of pi over 3. Okay, but again, because I'm in the second quadrant, thinking all students take classes, this needs to be a negative tangent of pi over 3. All right, now tangent of pi over 3 in degrees is 60 degrees, and the tangent of 60 degrees is the square root of 3, and I need to make it negative. So there's the answer, or you can just leave it like that. Okay, let's do 14. The cosine of pi minus x. So when you have cosine with subtraction, you're going to write this as cosine of the first one times cosine of the second one. Change the sign to addition, the opposite sign, and then do sine of the first one times the sine of the second one. Okay? Now, again, if I use this is a quadrantal here. So pi is out here. This is pi. The ordered pair is negative 1, 0. So the cosine, which is x over r, that's going to be, the cosine of pi is negative 1 times cosine x plus, and the sine of pi is y over r, right? So if x was negative 1, y is 0. This is going to be 0 times the sine of x. 0 times anything is 0, so my answer just becomes negative cosine of x. All right, last one for this section. 2 cosine squared of 15 degrees minus 1 can be rewritten as the cosine of 2a. In this case, a is 15 degrees. So the cosine of 30 degrees. Again, that's totally fine. Just leave it like that. Or if you want to go farther or look at your calculator, the cosine of 30 degrees is going to be the square root of 3 over 2. All right, so that does it for this section, all right, which is, as you saw with all these questions from 9 through 15, was more about our double angle identities, our sum and difference identities, and then there was even a question with tangent. All right, so I want to get to 16 and 17, which is kind of a little bit of a continuation of that, okay? So for this one, number 16, it says, use this information to find tangent of a plus b. Well, let's just write down the formula for the tangent of a plus b. All right, so again, you're using your formula sheet here, which is the tangent of a plus the tangent of b over 1 minus the tangent of a times the tangent of b. Now, this problem, I hope you see, we already have all this information. We have the tangent of A, we have the tangent of B. So this becomes very much just a plug it in and go to Desmos. So that's going to be negative 5/2 plus 4/7 all over 1 minus negative 5/2 times 4/7. So I'm going to go to Desmos and type this in. Okay, so I've got negative 5/2 plus 4/7 is in the numerator. So we have negative 5/2 plus 4/7 is in the numerator, all over 1 minus negative 5/2 times 4/7 in the denominator. All right, so you can write the decimal if you want. That works, negative 0.794, but I'm going to use the fraction, right? So this button here changes it to a fraction, but totally fine. My answer key will have both. So negative 27 over 34. Okay, now let's go to 17. 17 is going to require a little bit more work because number 17 says use this information to find the sine of 2 times theta. So if you go to your identities, the sine of 2 theta is 2 times the sine of theta cosine theta. So I actually need the sine of theta and the cosine theta, and they don't give us that. They give me the tangent of theta, great, but I need to find sine and cosine. So let's go ahead and figure out where this theta is first. It says theta is between pi over 2, so that's up here, and 3 pi over 2. So it's going to be either in the second or the third quadrant. Now, if you think back to your all students take classes, so all students take classes, you'll see tangent is positive 5/4. So which quadrant is tangent positive between the second quadrant and the third quadrant? That would be the third quadrant. All right. So my theta is going to go all the way around to here. I'm going to make my triangle like we've done before. Okay. Now let's talk about tangent, because we know that the tangent of theta is 5/4. Okay. Now there's a couple ways you can write tangent. Tangent is the opposite side over the adjacent side, which is the same as y over x. So if this is my theta all the way around, right, the whole way around, then when I look at the opposite side, that's my y, and the adjacent side is my x. So I'm going to write the opposite side, which is 5, and the adjacent side, which is 4. Now, here's the thing, guys, okay? If you take a look at this, you'll notice that tangent is positive, but I'm going down in the y direction, all right, and I'm going to the left in the x direction. So they actually, what's interesting here is that the y is negative 5 and the x is negative 4, okay? So that becomes positive 5/4, but just to make sure you understand that my side lengths for x and y are in fact negative. That matters because I'm going to use x for cosine and y for sine. Now let's get the hypotenuse. All right, the hypotenuse we're going to need to use Pythagorean theorem, which is negative 4 squared plus negative 5 squared equals our hypotenuse squared, or r. Okay, so this is r. So that's going to be 16 plus 25 equals r squared. So that's 41 equals r squared. So r is the square root of 41. Now, I've said this in the past, but when you do the square root of both sides, you have to be thinking plus or minus. But because we're finding the hypotenuse or letter r is always going to be positive. So r is positive square root of 41. Okay, so now let's try to find this 2 times the sine theta times cosine theta. All right, so here we go. Let's do some work. So 2 times the sine of theta, all right, the sine of theta, if here's my theta, is are opposite over hypotenuse. So opposite is -5, and hypotenuse is the square root of 41, or y over r. Cosine is the adjacent side, so x, which is -4, over the hypotenuse, or r, which is the square root of 41. So that's going to be -4 over the square root of 41. So I'm going to type this into Desmos, and that will give me my answer. All right, so 2 times -5 over the square root of 41 times -4 over the square root of 41. So here we go. 2 times -5 over the square root of 41 times -4 over the square root of 41. Again, decimal's fine. So my answer key would have 0.976. I'm going to hit this button when I can to make it a fraction. So 40 over 41. All right, so as I said, we ended up using one of those identities we've used in the past, but there was a little bit more work to do because we had to find our side lengths to find sine and cosine. All right, let's go to number 18. Now, 18 through 20, the last 3 questions, are proofs. All right, these are challenging, guys, okay? So again, it's your choice. I just said verify, so you can choose whichever side you want to simplify to look like the other side. My recommendation is to pick the one with the most stuff, all right? So when I look at 18, the left side to me looks like it has the most stuff, right? And I notice, right, this is over 1. So if I want to get a common denominator to end up subtracting here, I need to multiply both the top and the bottom here by 1 minus cosine x, right, my other denominator. So that's going to leave me with 1 minus cosine x over 1 minus cosine x minus sine squared x over 1 minus cosine x. So I'm going to put those together to get 1 minus cosine x minus sine squared x over 1 minus cosine x. Okay? Now I'm going to use one of those Pythagorean identities, which I've used in the past. Right? Sine squared x plus cosine squared x equals 1. All right? If I move this sine squared over with subtraction, I get cosine squared x equals 1 minus sine squared x. And I don't know if you see it. I'll highlight it if you don't see it. But we actually have 1 minus sine squared x here. We have 1 minus sine squared x. Okay? So I'm going to replace that with cosine squared x. So this becomes cosine squared x minus cosine x, all right, over 1 minus cosine x. Now the numerator, right, has cosine squared x minus cosine x, which means you can factor out a cosine x. So I'm going to take out a cosine x and write cosine x minus 1. And if you look at what I factored and the denominator, they're really close, right? Cosine x minus 1 and 1 minus cosine x just have different signs. So instead of factoring out cosine x, if I factor out negative cosine x, this would have to be a negative cosine x, and this would have to be a positive 1, which now matches my denominator. So I can go ahead and cross out. These two, which leaves me with just negative cosine x, which is what I wanted on the other side. Okay, let's try 19. Now 19, I might get some students that pick either side here. Again, I'm picking the side that I think has the most stuff going on. They look similar, but the left side has subtraction. So when I see that, I'm going to go ahead and pick the left side. is that allows me to get like common denominators. So 1 over sine of x minus cosecant of x, right? 1 over cosecant is the same as sine of x. So to get a common denominator, I need to multiply this one on the right by sine of x over sine of x. Now that gives me 1 over sine of x minus sine squared x over the sine of x. Okay, so now I can put them together. They have common denominators. So 1 minus sine squared x over sine of x. Now, when I look at this numerator, it sure looks like it's almost one of my Pythagorean identities. Again, sine squared x plus cosine squared x equals 1. If I move the sine squared over with subtraction, I get cosine squared x equals 1 minus sine squared x, right? That's what I have in my numerator. So I'm going to replace the numerator with cosine squared x over sine of x. Now, I'm not there yet, all right? But if you look, right, I have 2 cosines in the top. So I can write this as cosine of x over, I guess I'll do it this way, cosine of x over 1 times cosine of x over sine of x, all right? And cosine of x over sine of x is the same as cotangent of x. So this becomes cosine of x times cotangent of x, which is the other side. All right, let's go to number 20. Last one. Now, when I look at number 20, again, they kind of look a little similar in terms of how much stuff they have, but I see secant to the 4th power of x minus tangent to the 4th power of x. That is dots. That's the difference of 2 squares. So I'm going to factor the left side to be secant squared x minus tangent squared x times secant squared x plus tangent squared x. Now, you probably guessed it, but I'm going to use one of my Pythagorean identities. 1 plus tangent squared x equals secant squared x. And if I move tangent squared x over to the other side with subtraction, I get 1 equals secant squared x minus tangent squared x. And now look at that. I literally have secant squared x minus tangent squared x on the left side. I'll highlight it to see if it helps your brain here. Right? I have this right here. So I'm going to replace that with the number 1. So that's going to be 1 times secant squared x plus tangent squared x. Now, if I use my identity again, okay, and I replace, let me see if I can show you with a different highlighting color, right? If I replace secant squared, which is right here, with 1 plus tangent squared x, I can write this as 1 times 1 plus tangent squared x, right, in parentheses, plus tangent squared x. Okay, now there's a lot going on here. This one that's in the front, I don't care about anymore. I can take the parentheses off. Let's just take all the parentheses off since we don't have any distributing that's going to change the values. I think you'll see it. So I have 2 instances of tangent squared x. So that becomes 1 plus 2 tangent squared x, which is what I wanted on the right side. All right. Okay, so again, hopefully you had a chance to try these. You're watching the video. Hopefully you made it through. I know it's a long video, but hopefully you'll feel confident enough to do well on this test. It's our last test for this semester until we get to the midterm. So good luck.